So I'm pretty sure you know what this is. If you've ever been to a New Year's Eve party, I'm sure you would have seen a light stick or a glow stick before. I want you to have a close look at this and see that there's a tube within the tube. So that's a glass tube within the plastic tube, and that separates the two chemicals. So you can see there's a chemical on the outside of the glass tube and a chemical on the inside of the glass tube. So you know the drill. I'm going to bend this and give it a shake, and when I do so, the two chemicals mix and a chemical reaction occurs. We've got the two chemicals here. I snap, listen to this. You can hear that snap? Okay, and now I give it a shake. Now I'm going to turn the lights off. And as you can see, we have got light, a glow stick. So, this reaction between two chemicals, they were separated before the reaction. I snapped it and shook it. A chemical reaction occurred, and energy has been released. Energy is released in the form of light. Interestingly, in this particular reaction, there's no heat being released. However, energy is still being released in the form of light. Now, this is the type of reaction that we call an exothermic reaction. An exothermic reaction is a chemical reaction that releases energy. Now, that energy could be released in the form of heat. So, in that case, the temperature of the products is higher than the temperature of the reactants. It could be the energy is released in the form of light, or it could be both of those. Sometimes also we hear energy released in the form of sound, for example, an explosion. So it's energy that's being released. And a great way to think about that is, so it's thermic. Thermic relates to heat, and exo, so I think about the heat exiting. So the heat is released, the heat energy or the energy is released in that chemical reaction. So what's happening is the energy is stored within the bonds of the reactants. So when they are broken to be rearranged, the energy is released. So that's an exothermic reaction. Some examples of exothermic reactions would include combustion, so burning, any of the burning reactions. A combustion reaction is exothermic, and an acid metal reaction is exothermic. The other one we've got is endothermic, and you probably guessed that endothermic is a chemical reaction that absorbs energy. So it absorbs energy. So that means that the temperature of the products is less than the temperature of the reactants. So that means that when the molecules are rearranged to form new bonds in the products, energy is actually being absorbed and stored within those bonds. So the temperature actually decreases. The temperature of the products is less than the temperature of the reactants. So the temperature decreases. Some examples of endothermic reactions include photosynthesis. So when you think about it, photosynthesis, a process of plants taking energy from the sun and holding it within glucose. It's actually, so the bonds within glucose contain a lot of energy, and that energy comes from the sun. So photosynthesis, absorbs and stores energy. So that one is hard to understand. An easier one to understand would be a chemical cold pack. So not one that needs to go in the freezer, but one that's in the first aid kit at the football game. It's just got two chemicals inside it, a little bit like the glow stick. And when you break it up, you break the inner container, the chemicals mix and the temperature decreases because the products store the energy, they absorb the energy, and the temperature decreases. So how do we know that whether a chemical reaction is endothermic, exothermic, or neither? We can do an experiment really simply. All we need to do is measure the temperature of the reactants. So let's say here's our beaker, and we put in, so this is our one of our reactants. So this is a liquid reactant. Let's say, for example, this is hydrochloric acid, and we're going to add to it magnesium metal, and the magnesium metal is going to be in crystals. Okay. All right. So we can use a thermometer to measure the starting temperature. So we'll know the starting temperature. This is the variable that we're measuring. So what is that? These are the reactants. And then we're also going to measure the products. So in other words, we're going to add our magnesium to the hydrochloric acid, and they're going to react away. They're going to fizz. They're going to produce hydrogen gas. But also, what's going to happen to the temperature? So we're measuring the temperature before, and then we're measuring the temperature after. So by doing that, we're now measuring the temperature of the products. And we can see what happens. Does the temperature increase? If it increases, then it's an exothermic reaction. If the temperature decreases, then it is an endothermic reaction. So the way we can work out if it's an endo or an exothermic reaction is to measure the temperature of the reactants and compare it to the temperature of the products. So our thing that we're measuring is our dependent variable, and the thing that we're changing is reactants versus products, and that's our independent variable.